So I'll be sharing my screen. So can we all see my screen?
Yes, sir.
So as I said earlier, today we'll be going into data analysis and visualization. The reason why we could bring the aspect of data analysis because visualization is mostly used in data analysis. Though even in data science, we also use visualization when we work with data, but not as much as that of data analysis. Because in data analysis, you try to analyze data and get information from it, and you you calculate maybe average, calculate some statistical data, you perform some statistics on it, and you also visualize the results. Because when you visualize it, you'll be able to present it for others to have a quick glance at the result you've gotten. That is why we have something called dashboard in data analysis and the rest. So, but the reason why you hear us talking about majorly data analysis and data science more is because this is the common aspect we use Python, we apply Python for. So in data analysis, we have some aspect of data analysis that you can use Python, but it's not majorly Python that we use. They use some other tools like Excel, Power BI. So, but Python, we have an aspect that also uses Python. If you use Python, you'll be able to do more with with what you are doing. So today we'll be going into data analysis and visualization, and we'll be using two common libraries, which is the Matplotlib and the Seaborn. So we use the Matplotlib for charting, while the Seaborn for statistical visualization. So the different type of visualizations that we have, you can have line plot, bar chart, scatter plot, histogram, histogram, plot, and heatmap. But I feel these ones are the common ones that we know is the line plot, the bar chart, scatter plot, and histogram, and even this heatmap. So heatmap is used is just like a kind of map. Let's say you have a map of maybe of Nigeria, and they want to show how people are populated in an area. So they will just you see different part of the map showing different colors. That is an example of its map. So I hope you are following. Hello.
Yes, I'm here.
Okay, all right. I just want to be sure. So for the line plot, we will be using Matplotlib for that. This track the trends and changes over time. For example, we can have a month, a period of time, and what are the changes we can see, maybe in the price of a product, or yeah, or in sales or anything. So that is what a line plot does. Is like one of the simplest graphs, plot charts that we can have. It's just as if most of us did when we are in school doing mathematics. There will be sometimes they will ask us to get a graph, and when you have a graph, you plot your x and y axis. You draw either a straight line or a curve on the graph. That is just an example of what a line plot looks like. So the purpose, it shows how a value changes over a continuous axis. Axis are like this straight, the horizontal and the vertical line when you have your y axis and you have your x axis. So, and when do we use line plots? Because all these charts and visualizations that we have, we need to know when to use them. We need to know when to use them. So we use line plots when we have time series data, maybe a stock price, temperature. Also when you have something that involves time and something that you want to see how the stuff is changing. Yeah. Maybe what is the how are people using internet in the past 20 years? We can carry out a research on that. So by the time you get your result, okay, you've gotten your data, then you not, because once you have the data and you want to really know, are people using internet increasing as the year goes by or reducing? So you can't be going through the tables all the time. You need to visualize it. By the time you visualize it, you really just be able to have a rough idea of people using the internet increases over time, and what is the change, the rate of change? Is it, did they increase exponentially, or do we have just a little increase? Visualization help you to do that. And line plots, we can use line plots for that.
Ah, what's happening? I think him. Okay.
Sorry, I just had to attend to something. So as I was saying, that is when we use line plots. So, and when not to use line plots, when your data has no natural order or sequence, maybe the stuff is not changing. Maybe you just have, you can use a bar chart for something that does not have an ordered category. So, and a visual tip, you can always add markers at some critical data points. Now, for example, here now that we have monthly sales for 2024 for a year, we have January, February, March, April, May, and June. So at this part now, because sometimes there's something we call grid. There are some lines we need to know when it comes to charts, graphs, and the rest. When you have horizontal line, all these, I don't know, all this line, when we have a straight line and a horizontal line, vertical and horizontal line crossing themselves, they form what we call grid. So now when we have a grid, and person just join, help us mute your mic. So when we have a grid now, you might be able to trace, okay, for January now, when you have the straight line, you can trace the straight line. Where is the sales for the month of January? You can trace that. But so it might not be all the time you'll be doing that. So you need to add what? Markers to it. So it makes it easy to know the value at that point. You also use grid lines. Yeah. I mentioned grid lines. I will try and see how to show you. Grid lines makes it easy for people to trace the point, but though it's not in all cases. And if you are using grid lines, we have different margins for it. You can just have a grid line at some point, or you can have a grid line between January and February. Now you can decide to have 5 grid lines in between them, or 30 grid lines to signify each days, or you can decide to just have those 2 grid lines. So that, and you can distinguish multiple lines with what? Colors and labels. There are some graphs that we might have, or some plots that might involve maybe monthly sales over a period of time, and we still want to get maybe the revenue that we generated over that period of time. We can plot, that is 2 different plots that we need. We can plot those 2 different things on the same line plot. So when you are having that scenario, you need to use what? Different colors. Maybe when we have this line will signify sales. When we have this blue and red line, it shows revenue. So those are just some visual tips. So I'll be heading over to an ID we use and just generate a line plot for us. And generate a line plot. Coming. Sorry. So I'll be using Google Colab just because of time. Because some of these libraries now, if you don't have them, if you are using it locally, you need to install them. Do I have it locally? if you are using it online, those times you have it installed, but if not, you install the libraries. So come in. Let me try and get the code. So I just want to repeat what we have here. Let me just copy what we have here. Exactly. We have to just type it. So I'll import matplotlib.pyplot as plt. Let me see if I can just have that. Import. I don't know why it's not copying at once. matplotlib.pyplot as plt. I also need numpy. Import numpy as np. Let me see if it's copy now. Hope you are still with me.
Yes, sir.
Let's
Yes.
not copy. So now we'll be having some months. We want to generate what we have months that we have in a year. You have sorry, it's a list that will create. We already know what a list is by this time. January, February, March. Because of time, I decided I want to copy it so it will be fast. April, because we still have a lot of other graphs we want to look at. April, let me just use the short form APR. June, April, May, and we have June. So I'll just stop for 6 months. June. So sales now. So I'm just trying to create a data. For example, if you already have a data set, you can just import your data set and use them. So now I'll just have some data, 150 for the first month, 180, 220, 190, 230, 280. So we already have that. Then we will create our plot. This one is just the data we want to plot the graph. These two data, 1, 2, 3, 4, 5, 6. Yeah. 6. Then we need to plot our line plots. You can see that already here we said import matplotlib.py plot as plt. So this is an alias. It makes it easier to use that library that we imported, matplotlib that we imported. So now we will be plotting. So and we need what? We need to define some details. That's why I was saying there are some parameters that we need to know. Let me just leave this here. There are some things that we need to know when it comes to graph and plots, chart and the rest. We need to define our axis. They are what we call axis. So now for our axis here now, we'll be having the y-axis and x-axis. I believe most of us are familiar with graphs. Or do you have anyone not familiar with it? So I can just explain that maybe briefly. So we have what we call the x-axis and the y-axis. So we need to define this where we have our month, January. This one is the x-axis, and normally our sales, we are meant to have a line where we have our sales. That will be the y-axis. I don't know if I can remove this. It's disturbing me. That will be the y-axis. So now I'm just defining that we have our month. So this is where our month will be, the x-axis, and our y-axis will be what? Sales. The x-axis is the first one. X comes before y. So x-axis, y-axis. So this marker now, how do I want my line to be shown? So I want it to use a O marker. I can decide for it to use the plus. By the time we plot the graph, you'll see the difference between that. Then this, we are defining the parameters we want for our graph. The line width. How do you want the line to be thick? So you can give it the thickness, maybe 2, 4. We will see the difference. Then can you see X label is what? Month. But since I already have X label, Y label, I might decide not to use this. But let me comment this out. So the reason I'm commenting this out is the X label and Y label. I've already done that with this. But I can decide that I'm not using this and I'll still use this. It's my choice. Oh, no, sorry. I've not done that yet. That was a mistake. So what this month and sales is, what is the data that will be my x-axis? This is the data. We already have months here. So that's what we have here. We will be plotting months against what? Sales. The graph of what? Of X against Y, month against sales. So that is what we have here. And we have some other parameters. So I need to label my X-axis to be what? As what? Month. And my Y-axis, which is the Y label, as what? Sales. So then the title, let's give it monthly sales for maybe year 2026. Monthly sales. Monthly sales year 2026. That will show this line is very important, because if you didn't put it, your plot won't show. This is just to show our plot. Then I need to add one more thing. I want it to show grid lines. So plot.grid, can you see it's already suggesting it's true. Then let me add alpha 0.3. So let me try and bring this full screen. So I'll try and run this and we'll see the result of the graph. So it's connecting to the runtime. So that is why it's taking time. So while that is running, so we'll try and plot this line plot. We'll do this. So while that is running, we also have what is called bar chart. So this bar chart can also be done using what? Matplotlib. So once we are done with our line plot, we also come to bar charts. All these ones are common charts that we have for visualization. Histograms, scatter plots. So those are the common visualizations that we have. Now we've generated our graph. Can you see it? Let me know if you can see it.
Yes, sir, I can see it.
Yeah, so you can see that all this now, I can decide to comment some things out here and you'll be seeing the difference. This title now, plot title, if I didn't add this title, I'll still have my graph. Let me comment all this X label, Y label out, and you'll be seeing that it will still plot the graph, but the graph, like it won't be showing some details for someone else to understand. So if anybody is seeing the graph I plot, they won't understand what the graph is about. Can you see? It still plots it. But someone will not know, oh, is this for revenue? Is this for sales? Is this amount? So the person will not know what the graph is for. That is the essence of we having what all this, the title, the Y label, and I can decide to add something to the sales. Our sales now is in what unit? Is it in dollars? Is it in naira? Let me put dollars, in thousands of dollars. Yeah, thousands. Sorry, thousands of dollars. In thousands of dollars. Or let me just put, yeah, in thousands of dollars. So, and also we will see these markers now. And you see in thousands of dollars have indicated the unit. So $220,000, like that. So now I can decide to, you can see this 00 points now. So this is our marker. So at June now, it's easy. You can see the importance of marker now, that at January, we are seeing a O marker. So it's easy to trace. And you notice you are seeing a grid line. All this box is the grid line. It makes it easy to trace. I can trace this February now, this line to this place. So I mean for February, we have what? $180,000. So if I decide to remove the grid line, if I want to remove the grid line, I can just remove it or make this place false. So, but let me just comment it out. I can decide to still leave it and put false. Then this O marker, let me change it to plus. You see the difference. I've changed it to plus. So you can see plus sign there now. That is our marker. But you can see you are not seeing any box here. So if I should have this now, it will be very hard for me to trace. Let's say I have 181 or 185 somewhere here. Let me change this to 185. Let me change this marker. I can decide to use this type of marker also. We have this. But let me use O marker is the best. I can decide to change how the line too is being plotted. Instead of a normal straight line, I can decide to use broken lines and all that. So you can see, because there's no grid line and I've changed this to 181, I might be thinking February is still at $180. Meanwhile, I've already changed the value to what? $181. But when you have your grid line, that is part of the visual tips that was suggested. After the class, I will send this document so that we can also go through it ourselves. These visual tips that you add what markers and also use what grid lines for readability. So I'll run it and you see the grid lines. So you can see the grid lines now. So it's easy for me to now say, oh, February sales is no longer what $180, but now 181,000 what dollars. So that is for line plot. You can see how simple it is. So you can decide to, if you, it depends on your value, you can decide to, your values can form something like a curve. Yeah, it might not form a straight line like this, but it's because of our value we're having this. So now we'll be moving to the next plot, which is the bar chart. The bar chart. Let me create a new. Yeah, sorry, I lost my network. Yeah, we still here.
Yes, sir.
Yeah, so let me reshare my screen. So now, as I was saying, so we move to bar chart. So now let's say you created a form and you ask maybe or a poll now, for example, and people were picking options, maybe yes, no, maybe. And you want to actually visualize the response of people. How many people picked yes, how many people picked no, how many people picked maybe. In that kind of scenario, a line plot will not be suitable. It will not be suitable for that because line plot is used for something that changes over time, something that progresses over time. So, but when you want to distinguish between categories, how many things do we have in this category? How many, okay, this company is selling this product. They have 10 products that they sell. So, how many uh, products? What is the sales of each product? Product A has so number of sales. You can have that. So those are things we can use what bar chart for, to compare categories. Or we can say we have maybe four countries now. We want to know the number of or the population of people in each country. So now for Nigeria, maybe USA, Canada, and the rest. So each country, you can see that is a category. Each country will represent a category, and we put numbers of what of people there. So that is what a bar chart does. So you can see this is an example of a bar chart. So this one, we can have it the other way around where the product will be down while the sales now will be going up. We can do both. So when to use, when you have maybe sales by region, votes by party, I mentioned poll now. When you created a poll or people maybe all past student issues to be like category revenue by product line. These are just examples. It's more than that. So we now have two forms of this now. We have vertical and horizontal. This so vertical now is being used when you are comparing values. Now we want to compare this in the sales. Is the sales that we want to compare. So vertical is best for that. So, but if you are using horizontal, this is vertical. If you are using horizontal, so this product will be down while the sales will be going up. So this is a long category label that needs space. So if you have something that maybe like 10 categories, 20 categories, horizontal might be what might be good for that because they need space. But if it's something that is just two or four, vertical will be okay. So you can use any one. So, and visual tips that we have for bar chart is always add what the value labels. This value label now, because if you decide to have maybe product A, product B, product C, and D, and you have this graph here now, and you didn't put these numbers there, you won't be able to know the exact sales that we have. Because what is different from a what line plus that you'll be able to trace. So always add what values on label. Use distinct color, that is use different colors for each category. It's possible you use the same color, you can use that, but the best thing is to usually use different colors if possible, and also have clear axis title. What is that bar chart, what is that chart doing? Put the title there. So we'll be creating a bar chart here now. So I'll be creating another one here. So let me create products. Be having products. Sorry, I had to reload my the notebook because I lost my network at a point. So I have to reload it. So we'll be having our product. The slide contains the code we'll be needing. So we have product, then we have, let's say, product in what? A category, product A, product B. You can give the product a name if you want. It's your choice. It can be anything, product C and product D. Sorry. And product D. So we also have our sales, sales 450. Sorry, no need of sales will be in integers 450, 320, 250, 410. So then I'll now to plot our graphs now. You can see for this one now, we plotted a line plot. So this is the simplest. So, but for bar now, we're having bars. This one is to describe how our bars will be plot. So I'll be plotting what product and what and sales. But I want to add some more information to it now. We need colors. So I want different colors for what each of, because now how many categories do we have here now? We have 4 categories. How do you know the categories? This category 1, category 2, category 3, and 4. So I'll be needing 4 different what? 4 different colors. 4 different colors. So, or let me just put any, maybe it can change. Let me add, if I didn't put that there, it will just pick the default color. So let me add red, red, blue, blue, green, and brown. You can just give it any color you want, but just note that the color you'll be using must be visible. If you are, sometimes you can decide to change this background. You know this is white. You can decide to use a black background. So when you are using a black background now, for example, you know the colors you'll be using must complement that black background. Colors that will show very on black or maybe a blue background or anything. So always note that. Or now you are using a white background and you now decide that one of the colors of the bar should be white. You know that won't be visible. So that's why you must also know about that also. Control Z. So now we need to now plot our bar. So we'll be creating a loop here now for bar in each of this bar tab. Then our Y value now, we will need to what? Get height. So we'll get the height of it. Then we'll plot PLT because that is our Matplotlib. That is what we use for our Matplotlib library. That is the alias. So test, then we'll be having what? Coming. So we'll be having our bar test, then with our bar, there's a bracket, bar dot get x. Then we have this plus bar dot get width plus tab get width divided by 2, comma our y value. I can change this to a or anything. but let me just use y value. So when you get the width, if we want everything to be corresponding, so it will get the width, then divide by 2, then you have our y value, then you have your what? F of our y value, then it should what? It should center it. Then we also have our what? Our bottom. You center it to the bottom. So let's try and run this. Okay, we've now added one last thing, because without that last thing, our plot won't show. So, and that last thing is what? Sorry. Enter. So that last thing is plot.show. If it didn't show our plot, we won't see our graph. So now let's run this. There's an error somewhere. Can I get the line? 7. Where's the error coming from? I'm trying to find where the error is coming from. Y value, get the value of y. I think something is missing here. I don't need this button. Let me try running again. Let me try and fix the error. There is somewhere the error is returning. We have all this correct. Probably the delay. So there's an error in one of the lines. And the error now that we have now is now affecting. So you can see the numbers of lines bringing here 74 something is bringing it from the main library. So can you see what the error is? Hello, I don't know. Are we still here? Hello. If you can hear me, just let me hear you. I just need to confirm if you are still here. Can you all still hear me? So our error now is because of this missing bracket in front of this our y value now. Let me try and return something here. Bottom VA is equal to, we have bottom. So just because of that, that was what gave us an error. So now we now have a graph. Now you can see the colors I specified, but this does not, it did not have title, it did not have labels. So I need to add all those labels there because it's not making sense just having it without labels. So let me copy some of those labels from here. To see, now bring it here and just edit. So now for our X, we have our what? Our product. Then for our Y label, we have our sales. Then product sales comparison. That will be our title. Product sales comparison. So let me run this again. You can see product sales comparison, sales, and products. So this makes sense now. Then we can relate now. This is 450. You can relate, okay, this 450, this 320, this 250, and like that. So now I will now create another value for this, another one. Let me copy this whole line, Control C. So this one that we have here is the horizontal form. I will now have it in the vertical form. We have it in the vertical form. So I will have to swap now. So we'll be having sales, then products. Sales and products. Sales, then we have products. So I'm trying to swap what we have there. So let's try and see. Then this place. So let me try and just see the result we have. And before we put our label. So our product is here, okay. Our sales is here. But something has not changed yet. So let me see what we can change. Sorry, I don't know what's wrong with my network that is just going off. I apologize for that. So we've created a plot. I'm trying to have this. You can hear me?
Yes, sir.
Yeah, I think I've not shared my screen yet. So now, so we already have our plot here. So I'm trying to var. So I don't know where is my network is just trying to malfunction here. So now, okay, we already have this. So I'm trying to see what we can change here. Get y. Let me change this to our x var. Then we have this get y. Then I'll change this one to x var. Thus my labeling is what I'm changing. Let me remove this. No, no, it's not what I want. X. So I'll come back and solve this. So let's try and move to the other plot. So because of time. So the next one is what? Histogram scattered plot. Then after scattered plot, we'll go to histogram. Then we'll talk on its map. We won't be talking on the violin plot and the bus plots. But the slide will be shared for us to just go through it. So for the scattered plot, how the scattered plot works is it shows whether two variables are related. Yeah. So we just have, let's say we have different maybe score or so, we just pick different points. So we'll now check, is there any relationship between this thing and this thing? How do we know if they have relationship? It's by how close they are. So this scattered plots, mostly we even use it in data science when you are predicting when and there is this thing called k nearest neighbor. Yeah, k nearest, is it k nearest neighbor? We have k nearest neighbor. We also have k clusters when you create a cluster. So, well, k nearest neighbor, I think that's what I'm trying to point out. So when you calculate, there's a way you calculate all those values and weights and the rest. So by the time you have something, a value, something here, you have another one here, and they are very close, you can so review what relationship. So we use that for classifications. Can you see it reviews relationship, correlation, clusters between two continuous variables. So we can decide to use this maybe height versus weight, hours studied versus grade. So how is this applicable now um in this scenario? So we can say, okay, the scores of students and the hours they study. So how is the hours they studied related to the score that they are getting? Does it mean that if someone study for longer hours, the person will get a higher score? So we need to know if there is any relationship or correlation between them. This can be used even when you are doing your research work or carrying out a research. Oh, the hours people pressed on phone, the hours people use on phone rather, and their productivity level. We can get different those things. You get, oh, what is your productivity level at this time of the day? How long so we can check, is there any correlation between them? So that is what scattered plot does. So we need to know when to use each different plots. We need to know when to use them. We don't just use any one anyhow. So now this, we can add a trend line to it or regression line to make correlation visually obvious. So color point by category, vary the dot size and add a third dimension for boot charts. So we'll try and create this scattered plot also. Let me try and have it here. So now we'll be relating the hours students studied with their score. How is it related? How, if you study for 2 hours and the score you get, is it really related how long you studied, or is a result of how far you are able to assimilate, or is there any relationship with it? So we'll try and do that. Scattered and scatter plot rather. So now we have the study hours. Let me just name it hours. Hours studied. You have 2, 4, 3, 6, 5, 7, 8, 1, 4, and 5. Then the score the students are getting can have 65, 78, 72, 88, 85, 92, 95, 55, 75, and 82. So we have that. Then we will give it colors because we want to be able to differentiate. The colors will show us if they are related. Yeah, that is just it. So now we'll be creating like a condition. So if the score is less than so score, give us a particular color. If it's greater than, give us a particular color. So if score, so now I'll change this. If score is greater or equals to 70, if score is greater or equals to 70, it will show green. So if or else, it will show what? Red. For S in what? In score. Then we'll plot scattered, then hours and what? Hours, then with the score. C for colors, then with the score now is over 100. Wait, is it the score over 100? So we also need Z. Okay, let me add on this one. Study hours versus their test score. How is it related? So I also need to add something there. Z is equals to MP polyfit, the hours studies, then with 1. All these things, you don't need to cram all this syntax on your head. I don't know, the season, the time, the age where we are now has gone beyond cramming syntax. You can actually go online and get all the syntax for all these codes, or you can even use AI to generate it. But the thing now is comes to your understanding. I think I said it in one of the call. Your understanding, what are you trying to achieve? How can you achieve it? What are the things, the modifications you can make to get a good result? Once you understand your line of code, even now you can see when I faced an issue, instead of wasting time trying to troubleshoot what and the error will be. Because sometimes it's because even this code we're having is short. When you have a lot of lines of code and you face error sometimes, you can use AI to troubleshoot and save time. But if you don't understand the code or how it's being done, you might not be able to get the results you want. So poly Z, I don't think I need that. Okay, I still need it. Let me add it there. Poly Z, then plot hours, then P of hours, okay, of study. Then color is red. Let me add something else. A marker to it. B of this. Then show. I don't need a grid. Let me add a grid. All this now, you can see it automatically suggested it to me. It's done by AI. But you can see it's bringing a red line here. That means there's an error somewhere. But I already know what the error is there, that I need a bracket to complete that. Because I'm already familiar with all this syntax already. So now we will run this to see what it will generate. We are having an error somewhere here. Okay. Position argument follows a keyword. Okay. PZ. Okay. Then the study, which is the hours. I think this is where the error is trying to find it. Okay, it should have been here. Sorry. Maybe let me add it here. It might still bring error. If it brings error, I will remove that line. Yeah. So there is a formatting, this B that I have here, the marker idea, you can see this is the markers. This line is showing the sort of trend. Yeah, I can decide to remove it. It's showing the trend. So it should come before the color and some other parameters. So now the study hours and the score. So for people with the high score, because we said 100 now, someone scored 80 something around, 90 something here, 90 something. You can see that those people that have the high score, the study hour is relative to what? And their score is related to the hours they study. I don't know whether I can see it. Those that studied for less hours, 1 hour, you can see them getting the lowest. Those that study for 2 hours getting at least, it's still not above the pass mark. They studied for less hours. So we can deduce a lot of things from this graph here. These are types of questions you might be asked to answer a graph that for them to pass in their test or exam, they need to study for at least 3 hours. You can see someone that studied for 3 hours got 70 something. So they need to study for at least 3 hours. All these things, that is why we said it's mostly used by people in data analysis, because data analysts try to find informations from data. They try to draw insights. So now, from here now, you can carry out a research and you can draw some insights. Oh, based on these results we have here, this data that we have here, this and this can be deduced from it. This and this can be deduced. So that is what it does. And so when you know, okay, for this result I want to get, which plot is the best? Is it line plot? Is it bar chart? Or is it scattered plot? So that is something about it. So I can decide now to remove this line. You will see that you won't see the red line again. Can you see? You can't find the red line again. I decided to add a grid line so that you can be able to know, okay, this is 95. This is showing their score. So, but I can decide to add it back. So now I'll be going to you have two more plots. So now you have the histogram. This reveals how values are spread and where they are concentrated across a continuous range. The histogram might be similar to bar chart. We will say similar to bar chart. Yeah, you can see it because bar chart also looks like this. So when you have what? Maybe age, the salary, the test score, height, weight, is used for numeric data. Now, when you have that, now you can see that we calculated the mean. So now visual tips, add a vertical line, maybe at the mean or median. It depends on the statistics you want to use. So if you are using mean or median, add a line to show it. So for this age distribution now, the mean age is between 23 to 26. We can add a grid line to this. The grid line will show us the value there. So people from 20 to what? 20, maybe 24 or 25. How many are they? We know the numbers of people there, numbers of people here. We can calculate the numbers of people here. It's like the people that are above 26 are what? Are much. So we can just do what? Check how data are concentrated. Oh, people of this age are more concentrated or are more plenty than those people here. So that is what histogram does. So and for the code for that, we have that here, histogram.py, where you can just create a data and you plot the histogram. Assuming everything is copying, so it's something I can just copy and do, but because of time, trying to be fast. So now we also have histogram with what? KDE, kernel density estimate. This now, it shows the data that will plot another curve that will show the probability density, and some other things. So this is like a complex plot. It's a complex plot. This one shows distribution. This one shows relationship. You can see some other things here. This one shows trend. Line plots for trend is track trends. Bar chart compare categories. Scatter plot what shows relationship. Why histogram shows how are they distributed. People that are maybe in Nigeria, you have the population of people, the people that are more educated. Oh, will I use an histogram for that? Okay, what is this? And so we can say, okay, people that are educated are more distributed to this area than this area. So that is example of what histogram does. So we also have boss plots. This one shows quartiles and outliers. This one is for people if you are familiar with statistics, you will understand all this. Where we have the max, the median, the first quartile, third quartile. So, and another one I will want us to show is the heat map. Yeah, the heat map shows correlation matrix. It shows correlation matrix, and this correlation matrix is being used in data science, machine learning. When you are creating a model, is being used. So you can see when you have EDA means exploratory data analysis, and you want to find features that correlate. So let's say we have total bill that someone will pay. When you want to go and pay bill, maybe you give the person a tip. What is the size of the stuff you are paying bills for? Stuff like that, yeah. So you can ask, okay, how are these things? How is this feature? How many of these features are they related to themselves or they are not related? You can use what? Heat map to know that. You can use it to find the summary of pivot table, and you can see it here, confusion matrices in what? In machine learning, as I said earlier. So this heat map, volume plot, boss plot, histogram. No, this histogram is Matplotlib, but from histogram with KDE, all these ones use what? Seaborn. They use Seaborn libraries. You can see them here, Seaborn libraries. This is what they use. So we've been able to talk about the Matplotlib and what? And the Seaborn libraries. So examples of the code we need is included in the slide. You can copy and practice and improve it as you want. So I think I'll just stop here. So are you still with me, Precious? Precious. Hello. Maybe you're not on the call, maybe network. So we'll stop here for this check-in call. Then for those that did not join us, although the recordings will be sent, we'll have to go through this the videos again, through the recordings again, yeah, to get it. So, and the task for this week will be shared to the group. It will be shared to the group where we will use these libraries to create plots. The task can tell us the type of plots to create, while another one will tell us plots to create. There will also be like a form of, okay, we have this plot, these things are not included, these things are included. What is the problem with this plot? And how can you fix the issue? You have something like that. So during the week, the task will be sent, and you will need to do it, and you will upload it to GitHub. So we'll be ending the call here.